Okay, so 2.3 is about rational root theorem and about how we factor polynomials or find the factors of polynomials when they're not in a form as we've seen so far. So far, we know how to find the roots of a polynomial if we are given a factor. So if they tell us like x minus 2 is a factor, then we can continue to use like synthetic division or long division to find other factors. We know how to find the factors if it's already in factored form. Or if it is quadratic in pattern. Oh my goodness, quadratic in pattern. So this is where we have like an x to the fourth minus x squared minus 6. Like we could still x method this because it's in this quadratic pattern. But what if we are asked to find the roots of an equation with no other information? So this is cubic, so we need to figure out what are those three roots. Well, you can't do an x method on a cubic, and we aren't given something to start with that we could like do synthetic division. So we have to use rational root theorem. So this is what it says. If p is an integer factor of the constant term, so this is my constant term, okay? And so it's asking for integer factors. So positive 1 would be an integer factor because 1 times 1 is 1. And negative 1 would be an integer factor because negative 1 times negative 1 is also positive 1. So that's my p value. Q is an integer factor of the leading coefficient in standard form. So my leading coefficient here is also 1, meaning my factors of Q are also plus and minus 1. So if you can identify P and Q, then you know that every zero of the function will take the form, every rational zero, I should say, will take the form P over Q. So we're going to use this rational root theorem to determine possible rational roots, rational zeros, and then we'll test each using synthetic division. We can tell if something is a factor because when we get down to the end, we'll have no remainder. So if we end up without a remainder, we can say that yes, we know this is a factor, and we can keep working to find all of the factors. So for example, this is the example that we were just doing. We said P is going to be the factors of all of the constant. So the possible integer factors of 1 are plus and minus 1. And then we said the possible integer factors of the Q, which is the factors of our leading coefficient, would also be plus or minus 1. So the possible rational factors, if we have any, are plus or minus P over Q, 1 over 1, which is just plus or minus 1. So then these are, like I said, possible rational roots. It doesn't mean they always work, but we're going to test it. So let's try the factor x plus 1. So we'll set up our synthetic division. We take the opposite sign of the constant in the binomial, and then we set up our synthetic. We are missing a 0x squared, so we need to make sure we keep that in our placeholder. So 0x squared, 2x, 1. So do our synthetic division, negative 1, 2. No, negative 1 times negative 1, so 3, negative 3. We get a remainder, meaning this is not a factor. So let's try it with, we did x plus 1, let's try x minus 1. So we've got 1 in our box, 1, 0, 2, 1. Bring down the 1. So we get, again, another remainder. So neither 1 nor negative 1 is a rational root. So we are going to say no rational roots. You won't see this happen very much, like probably ever again in this class. You're always going to find at least one rational root, and then you can find other ones other ways. So this one, the way that we would solve it from here is we would need a calculator in order to find the intercept of the x. So let's try another one. All right, so we've got number 2 here, which is x to the 4th plus 2x cubed minus 7x squared minus 20x minus 12. So we have an x to the 4th. So we know that there could be up to 4 rational roots, right? Up to 4, because it's to the 4th power. So let's start by finding p, which are all of the possible factors of 12. So plus or minus 1, 12, 2, 6, 3, and 4. Those are all my factors of 12. And then q, which is the possible factors of my leading coefficient, which is 1, would just be plus or minus 1. So then we're going to take all of my p's and put them over q to get my possible rational roots. So we're just going to have everything over 1, which just basically repeats our p-values. 1, 2, 3, 4, 6, 12. These are all plus and minus, so we have to test the positive and negative possibilities for each of these. So let's start with x plus 1. So if we start with x plus 1, do the synthetic division, and minus 12. So 1, negative 1, negative 1, 8, 12, no, that's negative 12, positive 12. Okay, so this was a stroke of luck that the first one we tried turned out to be, oh my goodness gracious, a factor. Okay, so we know that this is one of the factors of this. Now, our answer is 1 degree less, so x to the 3rd plus x squared minus 8x minus 12. Well, we can't still do anything with a cubic without finding a factor. So we need to keep going. So we're going to continue with our synthetic division. We know that negative 1 worked, or x plus 1. So let's try x minus 1. And we're going to try it with the cubic that we just found. Because what we're trying to do is get down to something that then we can factor, that we know how to factor, which is a quadratic. So let's try this. This would be positive 1. And we have 1, 1, negative 8, negative 12. So 1, 2, 1 times 2 is 2, negative 6, and negative 6. So this does not work. So this is not a factor because we have that remainder. So we're going to keep going. Zoom in a little bit so I have more room. All right, let's try, x plus 2. Okay, so if we do x plus 2, let's test that. We're going to test it on our trinomial still. So this would be a minus 2 here. And then we've got our 1, 1, negative 8, negative 12. So negative 2, negative 1, 2, negative 6, positive 12. Okay, so that worked. Thank goodness. So this works. So now our answer is x squared minus x minus 6, which is a quadratic. So what we can do is use our x method to solve the other factors of this. So negative 3, positive 2, yes. So x minus 3, x plus 2. So now what I'm going to do is I'm going to take all these factors that I just found, and I'm going to solve each so that I know every single x. So we've got x plus 1 is a factor, x plus 2 is a factor. It's actually a factor twice. And then x minus 3. I set each of these to 0 to find my actual solution. So x equals negative 1, x equals negative 2. Remember multiplicity. When we have this squared, right, this is technically x plus 2 squared, that means it's going to be a bounce off of the x-axis at negative 2. And x equals 3. So those are all of my roots. Now, when the leading coefficient is not 1, the possible rational roots increase because we have more possibilities of what we have to solve for in order to find the rational roots. So for example, number 3, if we have 3x to the 3rd minus 7x squared minus 22x plus 8, we'll start off with p, which is the possible factors of the constant term. So we'll have plus or minus 1, 2, 4, and 8. And now, instead of just being over 1, our q has more possibilities. So it can be over plus or minus 1 or over plus or minus 3. So when we do our p over q, we're going to do all of the p's, because everything over 1. So plus or minus 1, 2, 4, 8. And then everything over 3. 1/3, 2/3, 4/3, 8/3. Those are all of our possible rational roots. Now we need to figure out which ones actually work. So let's start with the easy ones. We'll do synthetic division. So let's do x plus 1, which would be -1, and then 3, -7, -22, 8. -10, 20, -2, 2. So this does not work. So not a factor. Let's try x minus 1. So +1, 3, -7, -22, 8. 1 times 3 is 3, -4, -4, -26. So this is -26. This is not going to work either. Let's go on to 2. Let's do x plus 2. So we'll do a -2 out here. 3, -7, -22, 8. -6, -13, +26, 4, yay. -8, 0 remainder. So we know that this is one of our factors because we got that 0 remainder. So this was in the 3rd degree, right? Meaning now we have a quadratic, 3x squared minus 13x plus 4. We can factor this using the x method. 12, -13. So this would be -12, -1. Don't forget that a was not 1, so we have to divide these both by a. So we get -4 here. So we get x minus 4 and 3x minus 1. So these are all because it's the 3rd, all 3 of our roots. If I just put it over here to do my solving, we have x plus 2. We have x minus 4, and we have 3x minus 1. So x equals -2, x equals 4, and x equals 1/3. So -2, 4, 1/3. Those are my roots. And they're all ones that we predicted would be possible rational roots. We just now found what they are exactly. All right, let's try this one. Okay, so P16 is going to be plus or minus 1, 2, 4, 8, 16. And Q is 2, so plus or minus 1 and plus or minus 2. So our possible roots are plus or minus all of the whole numbers. So everything over 1. And then everything over 2. 1 over 2. As we go through the rest, 2 over 2 is 1. We already have that. 4 over 2 is 2. 8 over 2 is 4. We already have all these. So the only extra one we have to add here is 1/2. Now we got to start testing. So let's do x plus 1. So this would be a -1, 2, 4, -18, -4, 16. So -2, -2, 16, -16. Okay, so that worked. Yay. Check. Yes. So now we've got this cubic, 2x to the 3rd plus 2x squared minus 20x plus 16. And we can't factor a cubic yet until we get to a quadratic where we can x method. So we have to keep testing. So let's try x minus 1, see if that works. 2, 2, -20, 16. So now we're just doing this with the cubic because our hope is to get it into a quadratic where we can then just factor. So we'll do our synthetic division. 4, -16, -16. So this is a fantastic day because they're all working on the first try. Now we are at a quadratic. This is 2x squared plus 4x minus 16. Before I factor, I need to pull out that common factor of 2. X squared plus 2x minus 8. Then I can x method. -8, +2, +4, -2. So then we get x minus 2 and x plus 4. So all of my roots, if I solve for each, x equals -1, +1, +2, -4. Ideally, I'd love to have you put these in increasing order so that they go from least to greatest. But those are our 4 roots. Okay, also, this is rational root theorem, but you may see irrational roots and you do know how to solve for those. So remember the quadratic formula. X is equal to -b plus or minus the square root b squared minus 4ac all over 2a. So let's start here. You won't know to use it at the beginning. Like when we have a cubic, you can't use quadratic formula because it's not quadratic, but eventually we may need to use it. So let's start by doing our P and Q because that's how we have to get something out of the way to get this down to the second degree. So -4 is our constant term, so plus or minus 1, 2, 4. And our Q, leading coefficient, is 5, so plus or minus 1 or 5. So P over Q is going to be plus or minus 1, 2, 4, and then each of them over 5. So 1/5, 2/5, 4/5. And now let's start doing our math. So let's do x plus 1. So -1, 5, 5, -4, -4. -5, this is 0, so this becomes 0. This is -4, +4, so what a great day. This is one factor, because that worked. Then this, 5x squared minus 4 equals 0. We can just solve this using algebra. So add 4 to both sides. We get 5x squared equals 4. And then we'll divide both sides by 5. So we get that x squared equals 4/5. And the last step is to square root both sides. When we insert our own square root to solve, we must take both the positive and negative possibility of that root. So x equals the positive square root of 4 over 5, the negative square root of 4 over 5, and the first one, x plus 1, set equal to 0, which is -1. This kind of all got written over each other, but those are our answers. All right, let's do one more. Number 6. So P, factors of 2 would be plus or minus 1, plus or minus 2. And then Q is 12. This is going to be so many. 1, 2, 3, 4, 6, 12. So P over Q, first we're going to have just plus or minus 1 and 2. And then we have to put everything over 2. So plus or minus 1 half. 2 halves is 1. Plus or minus 1/3. And then 2/3. And then over 4, plus or minus 1/4. 2/4 is 1/2, so we're done. 1/6. 2/6 is 1/3. We already have that. And then 1/12. 2/12 is 1/6. We already have that. So these are our possible rational roots. I am going to skip ahead. None of these work. Okay? So if you had this on a test, you would be doing a lot of guessing and checking until you got to 1/3. So, and it's actually not even positive 1/3. It's this. Okay? So when we do our synthetic, we would have 1/3, 12, -1, -7, 2. All right, bring down the 12. 1/3 of 12 is 4. 4 minus 1 is 3. 1/3 of 3 is 1. Minus 7, -6. 1/3 of -6 is -2. So this is one of our roots. And then we have this 12x squared plus 3x minus 6 equals 0. Before we can even attempt to x method, we must pull out that common factor of 3. And then we can try to x method this. -8, +1. And there is nothing that factors. So we will use quadratic formula. A equals 4, B equals 1, C equals -2. So x equals -1 plus or minus the square root of 1 squared minus 4 times 4 times -2 all over 2 times 4. So we get x equals 1 plus or minus the square root. 4 times 4 is 16 times -2 is -32, and that's times a negative, so it's plus 32. So 32 plus 1, root 33 over 8. So this was cubic, right? If we go back, way back up here, this was cubic, so there are 3 roots. One is at +1/3. That's the green one. And then these are 2 roots because of plus or minus. So we have 1 plus root 33 over 8 and 1 minus root 33 over 8. And those are our 3 roots. One of the rational roots is there, and then the other 2 were irrational, but they still exist and we can find them.